For more interesting videos, subscribe to Tech Simplified TV and hit the bell icon for updates.
Hey guys, welcome to the 8th episode of PERL programming in VLSI. In this episode, we are going to discuss application of regular expression, that is regex, in VLSI, string operation in PERL, meta character and meta symbols in regular expression, pattern matching through regex in PERL, non-default delimiters, matched group and its extraction, split function and regex in PERL, and finally search and replace in PERL, which is very similar to what we have learned in the SED episode, okay, in bash programming. So without any further delay, let's begin. So before displaying anything in this slide, I would like to mention here that PERL regular expression is the most important feature while we use PERL in VLSI, data processing and automation purpose. Now in this slide and the next slide, I am going to share these ideas how these things are done in VLSI through infographics, okay, and watch till the end of this episode to know how the regular expression you can use, as well as these are very important if you are giving any interview for PERL or any particular role which has PERL. So let's begin. Say in VLSI, when we run any tool, it has dumped an output file. Generally the output file is a text file, and PERL can read a text file through the file operation, okay, and here generally these text output files will contain resistors, capacitors, etc. maybe, okay. So there could be any other thing. It depends upon whatever tool you are using and whatever the output it is giving. But for this particular slide and sake of example, let us consider whatever output file is coming from a particular tool contains different resistors and capacitors, and when they have say we are thinking that there are three things that is related to a particular resistor: current, voltage and slew, okay. So this is for resistor 1. So there are maybe thousands of such resistors and each will contain this data, and the text file which is containing is not a way that you can manipulate the data for your need. So it is a kind of haphazard way it is written, and even for opening and reading in text reader, okay, it may not give you a good option. Generally this data, if it can be exported into Excel, will give you a good result. Now sometimes this file may contain some other kind of comments and all, which may not be good for a Excel file, and you need this, say there might be several fields and you need maybe only 2 or 3 particular fields, okay. So PERL regular expression can match these particular strings like current, voltage and slew, and you can store the data in a PERL hash. Few episodes back I have discussed for a simple hash as well as hash of hash, okay. So if you have not watched, please go ahead and watch them. And now this PERL hash will contain all the resistors. So this data structure will contain all the data regarding to the coming out from that particular text file, okay. And here whatever I have shown is that res1 is the key, and again inside this key the value is there is another hash, okay. So where the key current is the key 1, voltage is the key 2 and slew is the key 3. So each will contain the different values, okay. So here just for exemplary purpose, now once we have this hash entirely populated, okay, with all the fields, there may be current, voltage, slew, load, there are multiple fields are there. You extracted your needful three things: current, voltage and slew. And if you want from this data structure, you can output a CSV file which you can read in Excel. Okay, and maybe you sort, okay, based on from lower to higher value of any particular field. Okay, and you can put a threshold and see what values are above it. Okay, so this is one good application of regular expression. For this matching, regular expression is widely used. Okay, and file IO operation discussed in previous episodes. You can watch that, and how to write a file, it is also already explained. So this is one particular scenario where a file parsing is done for your analysis purpose at the end. So why we need to do that? Say over the 1 year, maybe there are several design cycles, and each design cycle you might have to process 50 such text files. Okay, so it is not possible that if you go and do that manually every time. So you must have a script, Perl script, which does this exporting of one particular text file into a CSV, and then you can in Excel you can sort that, and you can very easily manipulate the data. Okay, so this is one example. We are done with this, and if you have any question, you can put your questions in the comment box. Okay, now let us move on to the next kind of operation where this regular expression is widely used. Benchmarking. Now benchmarking typically is done in VLSI. Now this is why it is done, because in a design house you will find that there are multi-vendor tools are used, say from vendor 1, vendor 2 and vendor 3. Okay, so you have the similar kind of, say for say you have a timing tool. Okay, timing tool from company 1, then timing tool from company 2 and timing tool from company 3. So for these 3 tools, or so let us keep one tool away, say only you have 2 tools. Okay, so you want to benchmark the results. This is done either you want to benchmark one tool to another, or it could be that you are making your data over sanguine. Okay, so it has not violated, or it has whatever the violations are coming, they are same in the two, or if you are not missing any violation. Okay, so there are multiple reasons why you want to benchmark the 2 outputs of the tool. Okay, so that if you missed one particular violation, what happens that when you go in the actual physical design and you go for tape out, after that you may have a silicon failure. No one wants that, because that's a very costly affair, and you have to catch this at the very beginning. So generally any design house uses at least similar tools from 2 vendors, and they run in both flow. Okay, so that their design is well checked and they are over sanguine that okay, our design is correct and whatever the violation is coming from tool A and tool B are same. So how this is done? So we are taking the same example of text file here. It is from tool A, and here I have drawn a container, which means that we have all the data in #1. Okay, and in the same Perl program we get with similar way we read the second tool output and populate a second hash, and now we are in a stage that we can compare the 2 data. Okay, we can iterate side by side the 2 kind of hash, and we can compare, say, resistance 1 versus resistance 1 in terms of current. So in tool A you can see it is 1.2 microamp, in tool B you can see it is 1.4 microamp. So similar, this way you can see how it is different. Now we create a, then we can compare these 2 hashes, okay, coming from tool A and tool B, and we can output in a comparative study. So it could be a text file or a CSV file based on whatever you want to have. Okay, so this scenario gives you gives your power to your hand. You become very much over sanguine that my design, whatever I have designed, is perfectly checked, and whatever violations, say 10 violation is coming from tool A and 10 violations is coming from tool B, they are very much same and coming from the same particular registers. Okay, this is the purpose. So for this you can use. So these are the two scenarios I have just discussed, and I have experienced such scenarios. That's why I'm able to share with you. And another thing is that here you can background when you are parsing those files, you are using the regex. Rest of the things you can use the for each loop and if condition, okay, etc., all these things. So and output will be using the file IO. Okay, so let me okay, so I'm concluding this slide. It's done. I think we can move on. So far in these two slides I have depicted the two different scenarios where we can use PERL regular expressions for a very critical kind of purpose, which is very much important in VLSI. Okay, so there could be many other scenarios and many other combinations where the regular expression can be used. Okay, for automation, even you want to check a file name, you can use it. Okay, I have given two explicit examples that are widely used in the industry, and let me go to the next one. So here whenever we are dealing with in PERL, right, we are dealing with string. So let's see something about the string, something we have already discussed in the first episode, but here we are rephrasing maybe some things we are rephrasing again, but still we need to go because the regular expression operates on string. Strings aren't technically separate data type, that is, they can be stored in scalars. So in PERL gives you a huge flexibility in terms of dealing with the string. So PERL do not have any data type, so any variable can store any kind of data, whether integer, real or string. Okay, so that is the very beauty of PERL when you are using. String quotes are like the standard delimiter for strings. Everything inside the single quotes can be taken as literally. That means whenever in under double quotes, if there is a dollar variable, it will be replaced, but if it is in a single quote, everything inside the single quoted string will be as is. Double quoted strings are interpolated. I just mentioned any variable names found inside the string will be replaced by their value. To compare two strings, we use the string comparison operators EQ, NE, LT, GT, LE and G. So this I have explained when I have explained the if condition already. Example: $animal is equal to camel. It's a pure string. Okay, then $sign I love a $animal. Okay, it's within the double quotes. Now this $animal will get replaced and it will become camel, and it will be stored in the $sign. Okay, string with interpolation. So here it is interpolated. Now my $cost is equal to it cost $100. Now $100 is not a variable. Okay, so it's $100. So it should stay as is. So here we are using a single quoted string. Okay, string without interpolation, and here we are using $CWD and backtick. Within that we are using PWD. So the output is a string of PWD and that goes into the $CWD. So this way the string can be flexibly used in PERL, and this is the power of PERL, I will say. And let us start about regex now. A regular expression is simply a pattern which is implicitly generates a family of strings expressed in a special notation. So guys, before going to the next point, I would like to mention in the bash series I have explained very much detail about this regular expression, and SED has come well before the PERL, and there are two kinds of engines. So you can go ahead and see that episode of SED in this channel if you want to explore in detail. But here in this episode I am covering the necessary things, so don't worry, keep watching till the end. A star Z, this pattern generates possibly family of strings, means A, AZ, AA, AAZ and multiply them Z. Okay, so this is called regular expression. The matching operator, that is /, returns true if the string it bounds matches with the regular expression that it contains. Okay, so we'll see later on. There are two pattern matching operators which are by default scalar and $_. These are the pattern matching operator, that is pattern within double slash returns true if the string matches with the regular expression which it contains, and the substitution operator, that is s slash pattern slash replacement slash replaces the pattern with the replacement if the match is found. So all these operators are operating on string, so that's why we touch base the string variables. Okay, most characters in a regular expression simply represent themselves. This is a good point, but why you are saying this? We'll come to know. Just wait for a while. Except backslash, pipe, braces, angular bracket, curly brace, caret, dollar, star, plus and question mark and dot. So these are special characters. So they are not treated as in the same way as the other characters in Perl. These are called meta characters and have special meanings. We'll come to know. Star I have already shown in the second bullet in this page. Later throughout the slide I'll explain. So we are done with the slides. Move on. Meta characters. Caret matches the beginning of a string. Dollar matches the end of a string. So basically a string is under a double quote or a single quote, right? So the first character of the string is after the opening single quote or double quote. So caret specifies that you have to match here, and dollar matches with the closing quote or double quote. Okay, so at that position. So that's why these are meta characters. Dot matches with a single character. Okay, any character, any single character. Okay, star matches with any count, that means 0 to n of the previous character. So there is one character A followed by star, means there could be any number of A. Plus matches the count but at least one of the previous character. So these star and plus, they have to come next to one particular character, and their count has to be matched, which is why these are different. Angular brackets. Okay, so these matches a set of character. Sometimes it is called a group. We'll see through the example. Then caret comes in the picture. This matches any character not a member of the set of characters following the caret. This parenthesis or the first bracket group a set of characters into a subspec. Okay, so we'll see how these are done. Okay, so this is a matching group. Okay, with the first bracket or brace. Now we have second bracket or curly brace. It exact, and the value here is m, that means it exactly matches m times. M comma here means at least m times. There is no maximum limit here. Then if we have m comma n, it matches at least m but not more than n times. So this is all the meta characters that we can use. Okay, so here m and n, they are just for exemplary purpose, but here they will be numbers in actual case. Okay, so we are done with this slide. Let's move on. Meta symbols. We have just covered the meta characters. Now let's see the meta symbols. \d matches a digit, not just 0 to 9 but also digits from non-Roman scripts. These are meta symbols. Okay, \s matches any white space character, which can be \space or \t, \r, \n, \f, and others. So this is used for a generic matching for the white space characters. So you can use it when you do not know which white space character is there. \w matches a word character, okay, alphanumeric or underscore, not just 0 to 9, A to Z and A to capital Z, but also digits and characters from the non-Roman script. \d is a negated of \d. So these meta symbols have their negated brothers also. Here, like \d is opposite to the \d. \s is a negated \s and represents any non-white space characters. \w is a negative of \w. It represents any non-word character. Okay. The period dot matches with any character but \n. Okay. Unless the modifier \s has an effect in and explained below. \n is like the period matches with any character but \n, but does so regardless of whatever the modifier /s is in effect. So these all you will see the examples throughout entire this particular episode. So don't worry, let's move on. Pattern matching. So here we generally say pattern matching, but it is actually a pattern and matching the pattern. So pattern and matching. Why I am saying these words, you will soon know. A, B, C, D, E, F matches the exact A, B, C, D, E, F. Now, if it is A star B matches 0 or more A followed by a single B, for example B, or multiple A then B. A question mark B matches B or AB. A plus B plus matches 1 or more A followed by 1 or more B, and the examples are AB is the shortest possible match. Other could be 4 times A then B, or A then 5 times B, or 6 times A and 7 times B. So these all can be matched with this particular regular expression. Now dot star or dot plus, these are two both matches all the characters in a string. However, the first matches with every string including empty string, while the second matches only strings contained at least one character. Okay. Now within angular bracket, A to Z, then capital A to capital Z, and 0 to 9, this matches any ASCII letters or digits. So it matches any alphanumeric combination. So these are basically examples and how you are using it. Okay. So let us now see some examples by which you will be able to know how you use the regular expression in actual PERL programming. So these are examples we will be going through, and here it is not a single example, multiple example will be there in each slide. So there are two kind of here. The first one is a positive match case. Okay, here we write hello world, and inside if we write the quoted hello world and equal to tilde, okay, or tilde, then we have world within the two forward slashes. So this is the case where we can match world with the string hello world, and it's a positive match. So if the return comes true, if it is matches, the return will be a positive one, and if this if block will be executed and it will say it matches, else it doesn't match. Okay, so we have explicitly mentioned the string here hello world. So and by condition we know that the if block will be executed. Now this is a kind of positive type of match. If we want to do a negative kind of match, how we would do that? If hello kids and then bang then tilde, then within the double slash we have world. Okay, so this means this string in the left hand side do not match with world, then it will return true. So if executed only when it is true, so in this case it doesn't match, we know, because hello kids and world by visually we know it doesn't match. So if will be executed. Else if you have not hard coded this particular string, we may have used a variable. In that case we have chances of getting into the two conditions, either in the if or in the else. Okay, so this is how it matches. So keep in your mind there are two type of matching. First one is a positive match, which is in the yellow box left side, and second one is a negative match, which is in the right hand side. So based on the situation you will choose whatever you need. Okay, so let's move on to the next slide. Here again we are seeing two examples. First is a positive match, and here we write $_ is equal to hello world. So these examples are making you also efficient for your interview questions, because here $world, say it can be that how you can match any particular string without using the string in a dollar variable or explicit. Okay, so this could be one example here. Okay, this could be answer. So here if we write $_ equal to hello world, means it goes to the default variable $_, and if we write if, then within the parenthesis we write only the world within two slashes. Okay, so it will match with $_ only, and here we use else block. So we know the string we have hard coded here, and we know that it will match, so the if block will be executed here. Second, it's also a positive match, but here we are using an explicit variable, $variable, and we write world, and here we are using if the string hello world equal to tilde with $variable within the double slash. So this is another way of using the regular expression matching. So here we know that in $variable we have stored the world, so this if will be true and it will print it matches. Otherwise if we have not anything else than world, if we write there, right, maybe a cat, so in that case else will have operated. So this is another set of example how you can use your regular expressions matching or something like that. These are different questions. This may come as an interview question. You can guess what the question will be. So please feel free to comment. Okay, and let's move on to the next example. Here there will be multiple examples. So first is within the double slash we have BA then *D. This in Perl we have the hash is as a the hash means hash character here. Okay, as a comment. So the rest of the line is a comment. Match 0 or more A's between B and D. Matches BD or BAD but not BID. Okay, BA plus D matches one or more A's. Okay, so there should be at least one match, so at least it will match with bad. Okay, BA ? D matches 0 or 1A. Okay, so you can guess what it will match. Please write in the comment. Now within double slash we have B pipe A then pipe D. This is alternation. Pipe means that exactly it has to match B, A or D. Now we have within the first parenthesis inside the double slash hard, pipe, soft, then ly. So this will match with hardly or softly. So this is kind of grouping. Okay, so either the hard then ly will be matched, or soft or ly, that is hardly or softly. Then hello world, and we have equal to tilde o slash matches o in hello, not in world. Okay, remember it matches with the first occurrence. If it is a non-greedy, right? If it is a greedy, then it will keep on matching. That hat is red, equal to tilde hat matches the hat, not the hat word, but that. Okay, so here it is a non-greedy matching, so it will match the first occurrence. Hello world matches with world, it doesn't match at all because the W is in small caps. Hello world, and then we have small o and capital W. Obviously it matches because we have the hello's O and world's W in the same fashion in the left hand side. Now here it matches hello world with O. There is no space in W, so it doesn't match because there is no character combination inside in the left hand side. So hello world and then the right hand world, and then there is a space. Remember, there is a space. So there is no character combination is there, world, there is space. You have to see that space in the right hand side, that is not in the left hand side. So this does not match. Okay, so these are very critical things. These are interview questions as well as you have to keep in mind because you have to be very careful when you are dealing with the regular expression programming in PERL. So let's move on to the next slide. Here will be multiple examples as earlier. So 2 plus 2 equal to 4 equal to tilde, then within slash we have used 2 plus 2. Now in the right hand side the plus is a meta character, so it doesn't match. Okay, we have a special meaning of plus here. Now 2 plus 2 equal to 4 equal to tilde 2, we precede the plus with a backslash. It matches because whenever we use a backslash before a meta character, the special purpose is now ignored, it becomes a normal. So now this backslash plus is treated like an ordinary plus in the right hand side, so this matches. The interval is 0 comma 1, then beginning we have angular bracket and then we have closing as a brace. So this gives if we do that, this gives a syntax error. Okay, you can try it why it is giving a syntax error, and please let me know in comment. Now the same thing at the left hand side and the right hand side, we have used backslashes everywhere. Okay, it matches because they were special characters. Now hash bang user bean PERL, we know the PERL basic path in our installation, it could be different in your case. So how to match that? We have to precede every slash forward slash with a backward slash on the right hand side, then it will match, otherwise it will not match because a forward slash is a meta character in regular expression in PERL. C colon backslash win32, so in the right hand side equal to tilde, that is what is happening here, we have to backslash the backslash, okay, so that it matches. My $foo is house cat equal to tilde $foo, so it matches. Next cat house cat $foo, again it matches. House cat $foo, then within curly brackets, right, $foo, again it matches. Housekeeper, and we have keeper in the right hand side, this matches. Housekeeper, and we have a carrot keeper in the right hand side, this doesn't match because keeper is not the beginning, is not at the beginning of this string in the left hand side. Housekeeper and then keeper followed by a dollar, it matches because keeper is the at the end point of the string and dollar is used for the demarcation of the end of a string. Now housekeeper, then backslash n, and we write keeper then dollar, okay, and it matches. Okay, now why? because \n is a special character, so it is not taking it in consideration. So we are done with the set of examples. Let's move on to the next slide. Example 5. Slash within cat matches cat. BCR within the angular bracket and then at. Okay, so it will match bat, cat or rat. Okay, so item, then 0, 1, 2, 3, 4 and so on, and we proceed up to 9 and then we close the angular bracket. This matches with item 0 or item 1 and then up to item 9. So you can understand how this angular bracket is used. What is the usage? ABC equal to tilde CAB within angular bracket. It matches only A, because in this group only one alphabet is matched, so that will match with A. Now we have three groups separate side by side: small y capital Y, small e capital E and small s capital H. So these can match yes in a very case sensitive way, that is small yes, then yes, and then capital yes, etc. and so on. So any combination. Item 0 to 9, so 0-9. So instead of writing whatever we have written in the third line, we can write in the similar fashion items, then within the bracket 0-9. So here it means the same, matches from item 0 up to item 9. Now here again we write 0 to 9 B, X to Z, then AA, matches OAA, sorry 0 AA, then 9 AA, and like all this thing. Okay, 0 to 9 A to F and capital A to F matches a hexadecimal digit. 0 to 9 A to Z and A to Z matches a word character like those in Perl variable name, and we have underscore here also. Now caret A and within the angular bracket and at, this doesn't match AAT or at, but matches bat, cat, 080, %80, etc. Next is caret 0 to 9. This matches a non-numeric character. Now A caret 80 matches AAT or caret 80. Here caret is ordinary. So we are done with these examples here. Let's move on. If you have a comment, you can do in the comment box. The next slide here is non-default delimiters. The // is the default delimiters for a match and can be changed to arbitrary delimiters by putting a within quote M out of the front. Okay. Now hello world equal to tilde, we have M, then within double bang matches world, and here the delimiter is bang. We have used M. In this case we have to use M. The second one is hello world equal to tilde M, then world, and we have two curly braces. Here the delimiter is curly braces, pair of opening and closing. M stands for matching. Okay, and with the double slash even we can use the M at the beginning of the first slash. Okay, in the same way. User bin Perl within double quotes, and here we are using M, then within double quotes / Perl, is it will match. Here the slash is not the slash for matching delimiters, it is a normal slash, and the delimitation character here is the double quotes. Slash becomes an ordinary character here. So these are some examples how you can use the non-default delimiters. Now in the third example in this page, you can easily imagine when there is a huge file name path you are matching, this kind of delimiters are very useful. How many numbers of / you have to use to make a non-special character for slash, okay, in the right hand side if you have to use. So this is very troublesome and you can get errors or something and by mistake in the typo, okay, and Perl may not recognize that. In that case, you will not get your desired result. So in such cases where you are matching a long path, this kind of non-default delimiters are very good to use. So done with these slides, let's move on. Extracting the match group. So this is a matching group. Earlier we have used the grouping in a different fashion. Here it is extracting match group. The syntax is different here. Now the grouping meta characters within first bracket or braces allow the extraction of the parts of a string that is matched. Okay. Now earlier we are checking whether a string is matching or not. Okay, that is a yes no condition. But here if the string is matching and we are matching a substring, how would we extract that substring? Okay, so the pair of braces do that, or the first bracket, whatever you call it, for each group. Okay, the part of the matched inside goes into the special variables like $1, $2. This is what I have already explained in the first episode. Okay, so these are special variables and these will contain the matches. So if you have 5 matches, so the 5 matching groups will be contained starting from $1 up to $5. Okay, they can just be used as ordinary variables. Now extract, let's see an example here. Extract hours and minutes, AM and PM. So we have my $hour, minute and designation. Okay, so here in the left hand side of the equal to tilde, we have 03:15 PM. So in the right hand side, how we are matching is slash, then within the first bracket we have \d/g. The first, there are two numerics here, digits. So we are using meta symbols here, okay, for matching. Now next is, you can see that for the minutes we have also \d/d, but that is covered in another pair of first bracket or braces. Then we have AM pipe PM, so that is AM or PM. Now, and in between there is a space. So we are matching every particular part and we can extract the each substrings here. Okay, so $hour we can set as $1, $minute is $2, okay, and $designation is $3. Now we can use this later on. Okay, so this is how we can use the grouping and extraction, okay, for substrings. Okay, so we are done with this particular slide and example. I think this is clear enough, and let's move on to the next slide. Matched group example. My $x, the cat in the hat, okay, is the string. Okay, and here we use $x equal to tilde caret, then $* is the first one, then at, then $*, and then we close the string with $. Okay, and it matches $1, the cat in the H. Okay, and $2 is at, so it has proceeded up to H of the hat in the first case because it is $*, and then it has to match at, so it matching at, and $3 has 0 matches. Wow, so this is a surprise, but you must get used to it and you can practice by printing these variables when you are matching. So that's how you gain expertise in Perl regular expression. Now let's talk about split function in Perl. Now we are discussing here about regular expression. Why suddenly we go for a function, split function? Yeah, it's necessary because in split function we also use the regular expression. So let's touch base it here. The split function is another place where the regular expression is used. It returns a list of values that don't match a given regex in a search string. So the pattern works here as a delimiter to split the string into smaller substring. The substrings are returned in the form of array. Now my $line is equal to Within quotes we have Linux, then colon DOS, then double colon Windows, then colon single colon, then BOS. Now my dollar at the rate output, it's array, and we use split functions. In the first argument we give double slash, here goes the regular expression, and we have the colon as the special character, okay, here or the character which we are matching in the regular expression, okay, and then dollar line we have just written it, and split the dollar line with respect to colon here in the decimeter. It's a very simple function, split. The first argument comes with the double slash, and inside that you put the character with which you want to split the string into multiple substrings, and the next one you give the string itself. So there are only two arguments, and the array will contain the split results. Now the array output contains Linux, DOS, and there is a blank string. Why? Because there are, after DOS there are two colons, okay, and then Windows, then BOS. Dollar underscore, next one is the dollar underscore is equal to, this is a test, and my words split with respect to a space. This is same as split and then dollar underscore, okay. So here we can, this is the purpose of showing this line, is that the split can take the dollar underscore by default. If you use the regular expression within the two slashes, okay, and you do not specify the second argument, that means the split is taking dollar underscore in the consideration of the string on which it has to operate. So this can come as an interview question also. So guys, we are done with the split function here. Here let's come to the next slide, search and replace. So guys, if you remember SED, or if you have not remember, you can go to the SED episode of bash programming in this channel. So there we have done the search and replace, that is very similar in PERL, okay. Search and replace are performed using S. S stands here for substitution, okay, and earlier we have used M here, which is for matching, okay. So here S, then within the first set of pair of slashes we have the regular expression, and in the next two slashes we have the replacement, and then at the last we can use the modifiers, okay. Modifiers you will come to know what are the modifiers. The folks who are very much using the SED, they know this kind of expression. So the replacement is a PERL double quoted string that replaces the string whatever it is matched with the regular expression. The operator equal to tilde is also used here to associate with the string with S, then slash, then slash, then slash, okay. If the matching against dollar underscore, the dollar underscore equal to tilde can be dropped, okay. So that means if we are using only starting from S, then within the three slashes we have our regular expression and its replacement, that means we are matching with the dollar underscore, okay. If there is a match, S then slash 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 returns the number of substitution made, okay. So this, if we are catching a value, right, this will give the number of substitution, otherwise it will return false. So this is the way we are doing the search and replace. Let's see some examples now. My $x, time to feed the cat. Now we have $x equal to tilde S, cat with dog, becomes time to feed the dog, okay. So this is a very easy example. Now $x is I battle 4 for 4. Now substitute 4 with word 4. It contains I battled for 4 but for 4. What happens to the next 4 which is in the numerics? It doesn't change because it's a non-greedy operation. I battled 4 for 4, again I write, and then I use S and then use 4 and 4 in numeric and word, and then I use G, here it becomes greedy, and it replaces all the 4s. So it now $x becomes, I battled 4 for 4. Okay, now all 4s are replaced with word 4. Reverse all the words in a string. We have $x, the cat in the hat. Now how we do that? We have $x, then s, then we have \w plus within the first bracket, then we use a function called reverse, and then we use $1, and then we do ge, okay, as a modifier, and it does the purpose. I would like to ask you to try this thing at your end and mention or not to mention the modifiers and see what the result. Okay, so guys, we are done with this particular slide. Now we reach the end. Thank you very much for listening up to this point. Please do subscribe the channel if you have not subscribed yet. Please like the video if you have liked the contents or at least one slide. Please do share with others so that others can get the help in the same fashion as you are getting. Okay, thank you very much, and bye for today.